Collecting wither skeleton skulls is an important part of progressing in Minecraft. You have to build a portal and trek through the nether until you find a nether fortress. Then you have to kill enough wither skeletons in order to get 3 wither skulls so that you can spawn in the wither so that you can get the nether star and build a beacon. Except I'm bad at the game, so it takes me forever to find a fortress, and then once I find it, there are no skeletons, and then once I do find skeletons, I'm still bad at the game, so instead of giving them a fair fight, I place these blocks so they only have a 2 high gap to walk through, but they're 3 blocks high so they can't fit. And then I just hit them till they die. But anyway, the point is, getting wither skeleton skulls is very important, and because of this, I want to know how frequently skeletons drop heads. Also, let's say that I've already done some Minecrafting already, so I have looting 3 on my netherite sword. Okay, math time. I want to estimate the percent of heads dropped by wither skeletons when using a looting 3 sword. To do this, I'm going to kill 320 wither skeletons and count the number of heads dropped. I will then use this data to set up a confidence interval for the proportion of wither skeletons that drop heads. For this video, I'm going to construct a normal approximation interval with a 95% confidence level, but first we need to collect our data. Alright, so I made this little area to spawn in 5 stacks of wither skeletons and see how many heads I get from killing them all. So of the 320 skeletons, I got 21 skulls. This means I have a sample proportion, or p-hat, of 21 over 320, or about 6.56%. But before we construct our interval, we need to First, we should make sure our sample is representative and independent. All wither skeletons are identical, so our sample is representative of all wither skeletons. For sampling without replacement, we need to make sure that our sample isn't bigger than 10% of the population. Since the population of all wither skeletons is virtually infinite, we can assume independence. Now, to construct a normal approximation, or Wald interval, we also need to check for large counts. More specifically, we need at least 10 successes and 10 failures. In this case, that means more than 10 skeletons dropped heads and more than 10 did not drop heads. This ensures a normal sampling distribution for our sample proportion. Since we had 21 heads and 299 non-heads, we fulfilled this condition. Now we just need to use this formula to construct our interval. The formula starts with our point estimate p-hat, then we need the margin of error. This part is the standard error, and we just plug in our numbers for that. Then we multiply the standard error by our critical z value to get the margin of error. Now we know our p-hat already, and our critical z is 1.96. You would get this value from a table for a standard normal curve. This number comes from the fact that the area under a normal curve within 1.96 standard deviations from the mean is 0.95, which corresponds to a 95% probability. You can also use that fact along with a calculator to calculate this value. The last value we need is the sample size, which in our case is 320. We just plug in all these values and find a confidence interval of 0.03849 to 0.09276, which is about 3.8% to 9.3%. So what do these numbers mean? Well, we can say that we are 95% confident that the true proportion of wither skeletons that drop heads when using a looting 3 sword is between the values of 3.8% and 9.3%. This interval is a little wide, but just for fun, how many skeletons should we kill if we wanted to get a margin of error of less than 1%? The margin of error is this part of the equation from before, and our critical z is still 1.96. Since we're assuming we don't know what p is, we want to set it to 0.5 because that maximizes the margin of error, giving us a conservative estimate. Then, we solve for the sample size when the margin of error is equal to 0.01 and get a sample size of 9,604. Now, if this was something important and not a YouTube video about Minecraft, then maybe you'd want a sample size that big, but I'm lazy so I don't really care. Okay, let's check and see how correct we were. The true proportion of wither skeletons that drop skulls when using looting 3, according to the Minecraft wiki, is 5.5%. At least on Java Edition, because it's different on Bedrock Edition for some reason. I love Java Bedrock parity issues so much. Well, maybe that's something I could test in another video, but not today. Right now, I'm figuring out how many more skeletons I have to kill and how much longer I have to run away from everything else in this nether fortress before I can go home to my cats. Anyway, thanks for watching. Goodbye.